So if you've ever taken a C course before, I know it says a review of your first C++ class, but C or C++. I'm going to talk about the differences between C and C++ because I saw majority of the people in the class have C but not C++, or they have had it maybe a long time ago. So we're going to kind of like, I'm going to spend the first, well, before lunch, in a major review. So if you're completely bored, don't worry, we're going to pick up the pace after lunch a little bit. And we'll start with classes and stuff after lunch. So this is for those benefit of those people who have not programmed in centuries, or have never programmed before, or never done anything. So I'm going to try and go as slow as possible. What do we have here? This is the skeleton. So C is function-based. C++ is class-based. Which is kind of weird because C++ also uses functions. So everything that you can do in C, you can do in C++. Everything that you can do in C, you can also do in Objective-C. So for those people who learn this backwards, usually you learn C++ and then you learn Objective-C. But some of you are in my Objective-C class, so you learned that one. They're both C++ and Objective-C are on the same level. They're object-oriented versions of C. They're just two separate dialects. Why there's two separate dialects? Well, they have pros and cons to each one of them. Objective-C is more object-oriented. C++ is makeshift object-oriented. I should say makeshift. It's not as object-oriented. It doesn't support true object orientation. It's kind of a hokey version of it. If you were to compare it with Objective-C. If you know Java, you know that's 100% object-oriented. And there's no way of programming in a non-object oriented fashion. So let me explain what object orientation is so we can have apples and oranges in comparison here. And I know there's a lot of people who don't like me bringing up different languages, but I personally think that's how I conceptualize things. And if you learn multiple programming languages, it's nice to know the differences between the languages. So C, not bad for embedded systems, not bad for systems programs. It was the original dialect of C that came out of B, that came out of Unix, essentially, if you go through the family hierarchy of programming languages. Meant for console applications. And then along came this thing called object orientation. People went, what about object orientation? Well, object orientation is an entire design methodology in itself. And what ended up happening with C is they said, well, okay, let's add some features to support it. And then we came out with this language C++, which is C plus object orientation. And then we have Objective-C, which is C plus object orientation. So it's the same kind of concept, two different languages. Java is not a dialect of C. Java is its own language itself. It came from a different family tree. What differentiates the two, and if you want to know a quick way of kind of figuring out am I in C or am I in C++, what libraries are you using? Are you using C++ libraries or are you using C libraries? And then also, am I using classes? Am I creating a class? So we have this construct called a class that turns into the object when it's instantiated. So we create these classes in C++. So unless you're actually using a class and creating what's called a class, I'm going to go through this as well, you're not using C++. You might be programming in C while using C++. Actually, you can do the same thing with Objective-C. You can write C code inside of Objective-C, inside of C++, but you're still not programming in object orientation. You're just programming in C. So the skeleton of the C program sort of looks like this, but this is the C++ skeleton. So let me show you the differences real quick. It's in the libraries. So if I go to, let's see, a few minutes ago, here it is right here actually. I wrote a different version of it, called it test.c++. This one's a little bit more color coordinated, a little easier to see because it's on a white background, probably a little bit from the distance there. This is C++ because we're using IOStream. Notice there's no .h on the end of it. That's because dev doesn't require it, and Xcode doesn't require it, but it's in here. So we have include.h. Some compilers, like Microsoft compilers, require the .h. Why? I don't know, syntax. So the syntax varies a little bit within compilers, usually in what's called the include. So this is an include. So an include is a compiler directive that says include, and what we're including is this precompiled header. And the precompiled header has a .h extension on the end of it. So this is the C++ version of it. What I'm doing right now is putting in a comment. So it's 2 forward slashes for comments. So this is not part of the compiled code. So this is the C++ include. And we have one that works with C. So if we go include IO string, oh excuse me, stdio, I have to, stdio. This is the C equivalent to IOStream. What does that mean? It's just a different library. Different features. C uses functions. C++ uses methods. Well, what's the difference? Well, it's the same kind of concept except for in C++ everything's an object, and the functionality that's associated with the object is implemented in terms of a method, when a method just really looks like a function actually. In C, there's no methods, there's no objects, there's nothing, there's just functions. What's a function? This is a function right here. So a function is a piece of reusable code. Not to go down too low in programming concept, but it's a way of writing something and then calling it, and writing something and then calling it. We have things called function prototypes, and we have functions that, you know, like for example, the main function that means something. Main will appear in every single one of your programs. So in a C program, we generally stick all the source code in one file, like this one right now. Everything's all in one file. In C++, we break it out and we have a separate main file. We still have the same type of file though, except for the file extension is different. In this one it says C++ on it, which if I had thought about it ahead of time, if you change this to C, it probably works with GCC. It's because the file extension is C++, it needs G++ to compile it, which is, you know, but now I think about it, that's what the problem was. But long story short, we have different methods that are associated with the different libraries that we're using, and we have different, it's a different way of programming, only in terms of the syntax that we're doing. So I'm going to leave this up here, I'm going to kind of build this program as we go through, and you can build it on your computer as well. The opening and the closing here is different than this syntax here. If we went and said include my header. So we have 2 different types of syntax here. This is going to be a file that I'm going to create, and usually I'm going to do this with it because I'm looking for an included file called my header. What's my header? It's going to be another text file. It's going to be just like this one, but instead of calling this one text.c++, we're going to call it myheader.h actually. So what we have are multiple files that we're using together. In the old days we had this thing called a make utility. You put the make, you separated the program out all into a bunch of different files. You included them inside of different files so you can reuse the code in different contexts. And then you made this make file, and the make file was kind of the configuration. So it found all the files and all the directories where it was located, and it put it all together, and it was basically compilation instructions. So now we have what's called projects instead of make. So the project is really the configuration. So for new people, when they open up Dev, it's like, do you want to create a project? Like, oh, what's a project? You get this thing called myproject.dev, and I'll show you that later on. And it's just basically a configuration file. It says this is in the project, this is in the project. It's like a folder, if you think of it that way, but it's usually stored in a folder. So you have all these extra files that go along with it. So for the purposes of this course and what we're doing is we're writing .c++ and .h files. That's all you need for this class. I don't really care what project you're using. In fact, what I'm going to do, when you send the project to me, if you just zip up the whole folder, if it's easier for you, then I'm going to go through and look for the .c++ files, look for the .h. So, alright, so let's go back to here. The skeleton. Every single program's got a main. This one's got a void in front of it. Void means it doesn't return anything. The one I wrote out here has int in front of it. It's a data type. I'm not going to go as low as data types, but just know that we have data types in the language. Main is not capitalized either. which is a common mistake for brand new people who are trying to do this. We have built-in data types, and then we have the name of the function that we're going to run. This is called main. Sometimes you'll see it this way. You'll see void inside. That's extra. You don't necessarily need to do that. That's C syntax. In C++, we take the voids out, and in C++, we have to return something, which is weird. In C, you never had to return something. You can have a void main. C++, now you got to return something. And most compilers won't allow you to make it void. Dev's not going to make it, won't allow you to make it void either if you're in C++, which is kind of weird. What does that mean? That means you're going to have this line down here, you're going to return something. Here we're going to return 0. We're returning the same data type that we're defining the method as. So if we had a float, a double, an integer, and this is where the deedle and deedle text is going to help you. Because I'm not going to go back as low as this is programming. Instead, I'm going to assume you have some concept of what a data type is. I'm going to review a little bit of the C++ data types, but for the most part, get yourself a deedle and deedle book and look up the concept of data types, and it'll bring you up to speed on that. That's the interesting part for those people who are familiar with C but not C++. In C, if we're using, let me take this out here. Actually, before I continue with this, I want to go backwards for a second and explain one thing here. These opening and closing arrows are telling you that it's in the compilation precompiled header directories, which is generally called include. There's a subdirectory, subfolder inside of your compiler called include that has iostream.o, and it has stdio.o. The .o is an object file. It's what's called a precompiled header. Precompiled header means instead of every time you compile your program going through and recompiling iostream and recompiling, these are standard libraries everybody uses. Why have to recompile it? Never changes. So when you use the syntax here with the opening and closing, you're just saying include this precompiled header. It's in the folder that's defined for my includes, which is the standard /include folder. No problem. When you use the quotation marks, and you have to use something, you can't just put the file name in there. It has to either be in quotes or it has to be in these little brackets, less than or greater than brackets. This says it's in my current directory and it's something I made, and it's not compiled. Could be compiled, but doesn't necessarily need to be compiled. If you remove all the .o files and you put this in here, you're going to get a compilation error. Because what's going to end up happening is, where's that precompiled header? Which is, in some compilers, the differences between putting the .h in and leaving the .h out. This is telling me that it's precompiled. It exists. It doesn't have a .h extension. It has a .o extension. But I'm not going to put this in here. Instead, for some people, some compilers actually used to do this. But it just put the name in there, and it just tells you it's a precompiled header, and it's in the object folder. So which is funny because like Visual C++ will require you to do this, put the .h in there. And because it wants consistency, everything's all the same. And sometimes you'll actually even put quotation marks instead. But the quotation marks are supposed to mean that it's in the same folder. So this isn't the same file location as this file here, if this were to exist. But it doesn't exist, so I'm going to take it out actually, because I'm going to get a compiler error when I use that. Then we got this guy down here, using namespace. And this is something that came out with C++. It's kind of, if you don't put it in there, sometimes it works just fine. If you do put it in there, sometimes you get an error message. Sometimes if you don't put it in there, it doesn't compile. It's one of those little tweaky things. What is it? A namespace is an environment that says, and inside of namespace standard, this was created for us automatically, std. What does it include? It actually includes this. So people got smart and said, well, we'll just put some precompiled headers that people are going to use all the time. Put it inside a namespace, and you can create a namespace. It's called create namespace, and you give it a name, and you put all these headers, and you define all this stuff inside of it. And then you just use the namespace. So using namespace standard means this is all the stuff that's inside of it. So this is kind of like a double. I put the includes in there, and then I'm also using a namespace. That's because dev requires this, actually. It's the compiler that requires. If your compiler doesn't require this, you're getting an error message on the namespace, take it out. Especially if you're using Visual Studio. Sometimes half those installs don't require a namespace. So namespace std has cout, cin, printf, scanf that are IO functions that belong to iostream.h and stdio.h, which are the precompiled headers, which are defined inside of this namespace, std. So this is the name of the namespace that we're using. It's happening before main. It's outside of main. It's in the project. It's in the file itself that's configuring the program that we're writing. All this entire program's all in one file. So just know that this is kind of the de facto standard in terms of namespaces. Why do we have this? Well, the idea of C and C++ is to use these third-party libraries and third-party tools and utilities and include them inside of our program that we're writing, which is why this is called include. This may not have been written by us, and it wasn't written by us actually, it was written by the compiler. We include them as kind of like imports in Java, if you're familiar with that. It's a way of saying, this is the functionality I'm going to use in the program, so here's the file that it's coming from, but we don't know exactly what's coming from it. But if we write something down here in main, and let's, for example, cout, it's inside of this. We have to include this, otherwise we're going to get a compile error, or we have to put the namespace in there, one or the other, or both if we want to. So what does this mean? We can create our own namespaces with our own different versions of iostream and stdio if we wanted to. Why would we want to do that? Well, the interesting thing about C and C++ is they're not cross-platform compatible. So, which is kind of interesting, which is why I don't want your binary file. You give me a .exe file or a .out file, or it's not going to do me any good. It's not compiled for my platform. And regardless of what platform I might be using, I have no idea what I'm going to be using when I'm testing your program. If you give me the source code, then I can compile it for my platform. Because my platform, as an example, here on this computer, I've got actually I have three separate platforms. I have a Windows 8, I have a Windows XP, and I have a Mac OS X Mountain Lion. When this gets compiled on my computer program, on my operating system, excuse me, it's going to use the iostream.h precompiled header for the Mac, which is different than the iostream precompiled header for the Windows system, and every different version of Windows actually for that matter. Which is interesting because this is actually, when I say precompiled, it's object code that's linked. So when my compiler works, it's taking different versions of different linked libraries and including them in so it works in the runtime environment on the computer that I'm programming this for, or that I'm compiling it for. Not cross-platform compatible. What does that mean? Well, if I compile it on a Mac, I cannot run it on a Windows system. If I compile it on a Windows, I cannot run it on a Mac, vice versa, which is different from Java. Java is a lot easier because you can just write it once and you run it everywhere you want, and because it runs in what's called the JVM, Java Virtual Machine. This doesn't. It runs on the native operating system, no JVM. So everything's all in one file. So when you write a C program or C++ program, you have a .exe file. You take it and you run it, and it works. No, all these separate little files that you have in Java, but it's all compiled together. Only works on the platform you compiled it for. So they call them precompiled headers because it's object-linked code for static compilation that occurs with C or C++. A little different. So you want to know, trivia-wise, the differences between C++ and Objective-C. Well, C++ is 100% statically allocated, statically bound. Statically everything is done statically. Objective-C is the dynamic equivalent to that. Everything is dynamically allocated, dynamically bound, which is kind of interesting. Different syntax, but get past the syntax a little bit and just think of the concept. Objective-C is made to run on a sort of like a JVM kind of environment, but it's still compiled, which is the most bizarre thing. It's like a hybrid compiled / dynamic language. I'm not going to get into static versus dynamic, but if you take it like a programming language concepts course, you'll get that information. But it has to do with when is the memory bound. So in C++ and C, we have things like pointers and alloc and malloc, and all these different ways of using memory. And at compile time, our program line instructions are allocating the memory for us. So by the time we get this .out file or .exe file, by the time we run it, everything's already pre-programmed for us. Everything is going to be set. it's going to run the same way. It might use different memory locations, but it's going to run the same way every time we run it. In a dynamically allocated environment like Objective-C, it changes depending upon how much memory you have available. So Objective-C actually has what's called garbage collection in there, or semi-automatic garbage collection. C++, no garbage collection. No automatic memory allocation, no dynamic stuff. But we can create it through the programming instructions using pointers, which is why we're going to look at pointers in this class. Because you're creating, and pointers is a C concept that was translated into C++, but it's a way of creating dynamically allocated objects that can come and go. So you can mimic the dynamic behavior in C++ to make equivalent to another language like Objective-C, which is kind of, yeah. I mean, that's kind of added information you don't necessarily need to know for the purposes of this course, but it's interesting to compare the languages. I think is interesting. So let's go back to the basic syntax that we're looking at. Cout. Well, the other one to cout is cin. Cin takes stuff in. Cout puts things to the floor, to the ground. So we have out and we have in. So if I go cin is the flip side of that. So really think of it like this: C, cin, cout, input, output. If you want to think of it that way. This is the C++ command syntax that goes along with iostream.h. So some of you might be familiar with iostream, stdio, standard IO, which uses two other complementary functions, printf and scanf. So these are what's called functions. So functions, and if we look at this function up here, comes in a certain format. Functions have opening and closing brackets that take parameters. So we can put parameters inside of the particular function. And as an example, if it's a print, it's going to print something. So we can do this, and we can say print another hello. And just for trivia purposes, so if you're brand new to programming, every single line of code that you're writing has a semicolon at the end of it. Just a syntax you're going to get if you're brand new. There's only a couple people that fell into that category. You put a semicolon at the end of each one of the lines here. In terms of the cin and the cout, they come in a set because they're part of iostream. These guys come in a set because they're part of stdio. It's just going to be the library calls. These are functions. These are methods. You can see the syntax is a little different. So this method here is equivalent to this function call here. So the function call takes inside of opening and closing brackets a parameter. Here we have this kind of this arrow thing going on, which is kind of interesting. So when you cout, you're putting something to the standard output. In Unix, some people might be familiar with the directional operators. So it's redirection to output. So you can put something, send input from here to output to there, back and forth. It's an old Unix concept. You put the symbol together like that, and then it differentiates between the, is it less than or greater than? So they had to come up with a symbol in the language to represent directional redirection. So they came up with the double arrows, put it together. So it's really a single arrow that says go out, but you can't use a single arrow, otherwise you can't tell if 5 is less than 10. You can't do comparisons. So output's easy. It's like a blowhorn. You speak, you go to a football game or something, you speak into the little microphone thing and it goes out, goes big this direction, it comes like, looks like little cones. You go, oh, it comes through the, well, you have the opposite that happens with cin. You're going to come in this way, so you have all the stuff that you're going to take in from the user, and you're going to stick it in something. Well, we have to put it in something here. So let's just do it here, integer data. So I defined a piece of data here, and then I'm going to cin data as an example. So I put cin to say, well, put it into data. So cin is not going to say, hey, enter in something. Instead, we have to put it out here. We have to go enter an integer. And then on the next line underneath it, or actually it's not going to be the next line underneath it. Instead, what we're going to have is, it's going to show up like on the same line, actually. And then in here we have integer data. Well, this is where we're going to store the data that we're going to take in here. So we have variables, just like any variable in another language. We have built-in data types like integer. We can go a float float F, double D. These are our built-in data types. So I get a datal and datal text and learn the built-in data types. In C++, we also have another one called string. So I can go like this, and I can say include string. Well, what's string going to give us? String is going to give us string as a data type. So notice that these data types that are built in are lowercase, lowercase I, lowercase f, lowercase d. The string is an object. It comes with object orientation, comes with C++, so that's always going to be uppercase. So we go string. Actually, this is going to be lowercase because of the way it's implemented in here. Actually, that's going to cause me a problem. I have to look up the syntax for in some compilers, and I think Objective-C, in Xcode is going to be lowercase. Dev is uppercase. So if you have a problem with string, check the case, because some compilers follow the true object-oriented version of the interpretation of what the object is supposed to represent. All objects in object orientation start with an uppercase, but if you get a C/C++ compiler, everything is in lowercase, because all your data types are normally lowercase. What does that mean if I lost anybody? It means if you're a built-in data type, you don't look like capital I. Oops, it's not going to let me do capital, is it? Well, alright, my compiler's not going to let me do that, but to put in a capital INT will come out as an error message. It's case sensitive, so it's a lowercase INT. Well, when I typed in string, when I was typing this down here, it changed it to lowercase for me, which means it won't allow me to enter it in uppercase, which means it's not going to take it. So this is going to be name as an example. And the name is a built-in word, so it's not going to allow me to use it, so I'm going to put here my name. My name. So I got a string defined. I don't know if this is going to compile or not, but we'll see later. So what I did is I included an object, and I made an instance of the object out here, which is kind of the same because it's a reference to a piece of data that I'm going to store. Well, I can put the same thing, and the reason why I'm doing it is because I can put the same thing down here. I can go name, or my name. So I can see in and see out, and the reason why I'm showing this to you is to demonstrate the point. I can see in and see out objects of string type, of non-built-in type that are part of C++. I can't do that in C. So if I go scanf, it's got to be one of my predefined built-in data types. I can't scanf a string. It's going to want a character array, or it's going to want a float or double. And what do I do there? Well, then in here I'm going to specify what I want. I'm not going to go through the syntax for this. It's going to be in the slide set. So, but I'm not going to be able to use object type. So when you start introducing objects into the language, and string is one of the classic objects that we're going to start out with, especially with the first program, then you're going to want to use the associated I/O stream that works with objects. And it works with more than just the built-in stuff. It works with the user-defined objects as well. So let's see what's happening over here. So we have our main point of execution, which is going to be main. And as I mentioned before, we're going to have an integer main instead of a void main. Go ahead and memorize this if you haven't done it already. Also, you're going to put it into a .c++ file. If you put it into a .c file, it gets treated like a C, not C++. You may have noticed some of the comments that I've been using so far. I use the C++ equivalent, which is the 2 lines. Your compiler will also accept, usually, will accept the other form of it, which is this syntax. But you have to do a closing bracket for it. So the 2 lines together is the entire line, and then the next line's not commented. This is for multiple lines. So you'll still see multiple lines done this way. In fact, it's easier to do this down here if I wanted to comment out the entire program. I've just commented out the entire program. It turned in green for me. Don't necessarily want to do that. It's not going to work. So I'll put it up over here. Which is why the color coding makes sense. Which is why I highly recommend using a compiler and not Notepad. Because then if that all turned green, I go, oh yeah, there's a problem here. It's all green. Well, green's going to tell me it's a comment, actually, because it's color-coded. So that's where we get that from. So here's our C in and our C out, as I mentioned before. We also have this end line that we get. So if we're going to compare the C in and C out, and we'll just look at that right now. If we wanted to, we could put in what they call an escape sequence for a new line. So we put in the /n. That's what's called an escape sequence. It also works over here. Or we can tack this up. So we can put in multiple outs, so we can print out multiple things. So as an example, here I can just add another one and put in another one here. Here's something else. Here's something. And then I can put in another set and put in, let's say, example, nline. Nline is going to be the command that says, well, put in a new line in the line and put in a line return at the end. So it'll put an extra line in there, and it's equivalent to doing this here. Well, we can also stick this in here too. We can also go like that. That works as well. Or the T. Those are another. T is a tab. /n is a new line. They're called escape sequences. They're used in functions. Well, it also translates over into this type of syntax as well. That works. So C out to do this is pronounced C out, and you can just do about anything with it. You can string together variables, multiple things together. You can use a new line with it, and you can use nline to drop to the next line. Here's some examples, more examples of C out, and which I don't have to type because they're in the slides here. So this is a sample string, and then here we have one with just nline at the end. And I don't believe the text code is going to color code that for me. Nope, it doesn't. It keeps it in black. But some compilers will actually make that blue, or will make it different colors. So in this slide set, all the keywords are in blue. Everything else is in black. So C++ scares me, just one line here, and then like I did before, hello world, with two of them. Actually, also stop me as I go through this, otherwise I'm going to assume this is a massive review for everybody, unless something is brand new. Or did you, is that, were you just stretching?
Yes,
or you do have a question, okay.
My program cannot recognize using namespace STD.
Take it out. What program are you using? Code blocks?
The dev
Ah. Did you get dev to work with the dow.c++ file?
Yes, I could with both of them, 1 and 2.
So that's both of them are using namespace std. If you've changed it, make sure that you have using namespace std above main, and you have a semicolon at the end of it, and you haven't misspelled it. And I can check it at the next break actually, but most likely you either have a typo.
Yeah.
Dev works with namespace. Yeah, if you don't put it in there, it won't work actually, which is kind of weird. So most likely it's a typo. All right. So getting input from the user, here's our cin, or pronounced cin. So here's some example. You can go, and this is what I was showing you before. My integer, cin, my integer. After you've declared my integer, print it out. Here we have my integer is, and then print it out. So on my space over here, I've got. If I put this up here, let's cut it. Actually, let's go back to the. Take the string out of here. I don't want to talk about string yet. We'll just put the data in here. I can actually add in here, you know, data. And that will print the data out for me as well. So we just, if it's quoted text, we want the text to print out, we put quotations and marks around it. If we want just the value to print out, we just put the value in there. So. And you can string things together. So it's a little bit more efficient than the printf. It's about the same thing. So here's some more examples of the cin, where we can go cin 2 items, age and name. So you have to put in, you know, the user will put in 2 items instead of 1 item in this particular case. So in this particular case here, they would be separating it by returns or by spaces. So it depends on how you want to design it. You can put it in terms of a return. Either one of them works. Actually, all of the extra characters are stripped out. So it's either going to be a new line or a space that's going to essentially trigger it. So in here, if I were to make this, I can go, actually let's just build this one here. Cin, let's cin the data first. And then we can go out here and go cout you entered. Let's see. Put a little space in there. Data. And then here I'm going to enter in something. Enter something. Enter an integer int value. Get rid of this one. We don't need this one. Actually, here we'll clean this up a little bit. Make this in C++. So if this were the case, and I wanted to compile and run this here, it probably, unless I've got some major syntax errors, it should run. And this is test.c++. So I've saved it. And if I go G++, and then I run it, no such input file. Let's see. It's a.out. There we go. It says enter an integer value, and then I'm going to enter 12, and I press return. You entered 12, and then I didn't put an end line in over here. So if I wanted to do that, I could go here, end line. So there you go. We also have, okay, so for those people who just watched what I did and kind of fumbled around with it, we can also specify the output file, which I didn't do. So if you're going to use a command line argument on that one, and I want to recompile this because I just changed it, I put that line return in. I added this little line here at the end, printing it out. So I'm going to go and recompile it. If I go G++, what was the name of that file? Test. This here is telling me it's in the current directory. So the // some terminals require that, some don't. I don't believe mine is actually going to require it, so I'm going to leave it out. Test C++, and I go -o for output name, and then I can go test, dot whatever, or just call it test, and then that will output it as a certain file name. So if I list it out, I see test now in here. Without, I have a.o. I have to remember that, actually. I haven't done this in years, actually. Usually I use dev for this, but I decided to use my Mac partition today, making things interesting for me. So now if I run it, I see enter an integer value. So I'll put 22 in here. Now I say you entered 22. And it goes back. So this is kind of like our hello world that I'm building. If we leave out the return, we're going to get an error message when we compile, because we have a function that we've defined with a data value, and the data value is int, so it's requiring a return. If I make this void, which is actually kind of an interesting, I want to see if it actually will work, and I take out the return and save it. Let's see if it compiles actually. Main must return int. So I'm going to have to go back and change it, so we'll go ahead and change it. You're going to get that in most of your modern day compilers. So, alright, so that was the C in and the C out. I think we've covered that one thoroughly. Chaining them together, which we saw a few minutes ago. There's no limit on the number of things that you can chain together, so you can print and read it. So we have first item, second item, third item, all chained out. These are those escape sequences I talked about. So we saw in there, we can use them just like we use, and these come from printf actually, so it was inherited from C. So we can use the /n for new line, a carriage return, /r. The tab, I would say the tab, the new line are used quite often. Beeps is kind of irritating. Backslashes, single quotes, double quotes, If you want to put quotes around things, you can't put a quote in there. It's going to think it's text. So you have to put in an escape sequence in here. If we had an apostrophe in there, we'd have to put the escape sequence before the apostrophe. So sometimes you'll see code like, like this. And that's just going to put the apostrophe in there. So if we put this in here just like that, actually if we did the quote like that and we have a problem, we're going to get a compiler error if we do either one of them. So. Alright, so here's another version of a hello world. We just did a better one actually, I think, because we have seen this out using in ours. But basic format. If you're brand new to programming, just memorize this. Actually, it's no other advice for you. You're going to have the includes on the top. The hash symbol is a compiler directive. It's kind of like the @ symbol in Objective-C, but in C we use the hash symbol, which is the number sign. So we can have a hash define, hash include, all sorts of different things. It tells the compiler to do something with that. So. Rules about the syntax. So where do the semicolons go? Everywhere. Yes? Uh-huh. It works in C. It does not work in C++. Yeah. Which is interesting because this is done in a C++ example because we have iostream.h.
Right, that's what I
Yeah. Actually, earlier C++ compilers will allow void. I believe that Visual Studio will also allow void in current modern day. And there's a little bit of inconsistency between the void and the, allowing it, not allowing it. Most Unix compilers won't allow it. Dev is a Unix compiler, is not going to allow it. Xcode's Unix compiler, or BSD Unix, so it's not going to compile it with void. Why? Because each calling program has to have a return to it, and that's the way the runtime environment figures out that something's executed and something has returned. If it doesn't return, which void doesn't return, if it doesn't return, we can't tell the program's over with. If we're the runtime environment, Unix can't tell. Nobody can tell. You have to take it for granted. So operating systems that do garbage collection want to return. If you return, it means remove you from memory. We're all done with you. So they just stick that in there. Does it really do the same thing? Yeah. If I put return 0, it's going to send 0 back. I can go -1 if I want, return 12, 15. But most people just put 0 in there because they have to return something. If you don't return something, you're going to have to fix it before it'll compile. So a lot of people actually take the other extreme and put void in here too. In fact, you can do that. I believe this will work just fine as well, but let's just try it out actually. You can put void in here, and then when you compile it, and it should work, which it does work. So one of the reasons actually why I like the command line arguments is because I can just use my up and down arrows from Unix and just get the history and just run everything. I have to type it in a couple times, so for demonstrating purposes it's easier. But you're probably going to find a GUI interface a little bit more user-friendly for you. So let's see, we also have the opening and closing blocks. Now this is an interesting thing here with the blocks. We don't get this as much in Java as we do in C++. People love to put the blocks in there. They'll go. In fact, blocks are legal everywhere. You can put the blocks in like this if you want to. Not going to cause a problem as long as you have them in a set. But why? So then you have people that don't understand why you're going to do that, that just put blocks in everywhere. That works as long as it's in the set. Or then there's people that will do the opposite and avoid the blocks, like not put them in at all. So there is only one case in which they're actually required, when you're blocking off a section of code. So because we have integer main up here, and this is going to be our main function for the program, we need the opening and closing block to signify where main is. If we don't put that in there, we don't have main defined. So functions define, functions implementations require the opening and closing bracket. Function prototypes don't. So if I were to make another function down here, and let me show you the opening and closing brackets, now I'm going to, starting with assignment number 1 actually, I'm just going to write a function. The function I'm going to write is going to be called sum. So I'm going to give it a data type, integer, because it's going to return an integer value, which is going to be the sum of 2 integers. I'm going to call it sum, and I'm going to take on 2 integers, an integer A and an integer B. And then I'm going to put it in an opening and a closing brackets and sets. And then in the Xcode is putting it in there for me automatically. I just press return and it put it in as I'm typing. You might find the same thing. And notice that this is outside. This is the other thing that beginning programmers generally have to work with if you've never worked with C and you're just, actually it's the same with Java actually. So if you're a brand new programmer, this is for you. This is a separate unit of compilation or block, you want to call it. I know it's a block because I'm using the opening and closing brackets. This is a separate block as well. If I stick this inside of here, it's going to belong to it, and I can't call it from it. It's already inside of it. So we take, instead of writing everything inside of main, we take the functionality and we pull it out of main, we break it out into smaller little modules or units, and we're breaking this out into functions. And in this function here, it's an integer, so I'm going to return something, and I'm going to return a plus b. Now, I can put spaces in there, I cannot put spaces in there, but this function here is just going to sum something up for me. If I want to use it, and I'm going to use it in main, the easiest thing to do is actually define it before main. Put it up above main here, actually. If you don't, you have to put what's called a function prototype up there. A function prototype says, I'm going to define this function, but it's not going to do it right now. I'm just going to do it further down the road. Because what ends up happening is inside of main, we're going to call the function. So if I'm going to call the function here, then I'm going to run it. Let's just do it. Actually, here, let me put this back up here, leave this alone. I'll put it underneath. Then I'm going to say sum 1, 2, or 1, 3, there we go. So that's a function call. And the function call itself is just ability to say, well, I have this function called sum, and I'm going to pass it 2 arguments. And I'm going to pass it 2 integer values. If I try to pass it a character, I'm going to get a compilation error because it's expecting an integer. So you have to call the function the same way as you define the function, which is the same thing that we're going to see with methods, actually. You're going to call the method and run the method the same way. So if I do that, it's going to run the function, but nothing's going to happen. I'm not going to see any output on the screen. Oops. So what I can do is create another integer. If I want to do another integer, I don't have to go like this. There's a couple of different philosophies. There's a lot of people like to do this. Output, or let's see, product, and sum num. So I got 2 variables defined on 2 different lines of code. I can do this instead. If they're both integers, I just put a comma in there. Now I got 2 of them defined on 1 line of code. So this is more of your review of basic syntax. You can also do this as well. You can just say it's 0 equals 0. So this is what they call a declaration and an assignment. In C++, we declare and then we assign separately. You're never going to do this in a class because you're going to have the constructors do the assignment for you instead. And I'm going to get to that after, probably not till after lunch, but this is a declaration because we're declaring the variables, and then we're doing an assignment because we're assigning it a value all in one shot. So sometimes also referred to it as an initialization. You're initializing, so it's a declaration and initialization, or a generic assignment when we assign it a value. So here if we say, you know, sum 1, 3, well, we can say sum, because we're returning, this is actually getting into the concept of returning. This is returning a plus b, so if it's going to return it, I'm going to get it back inside of main. So the return sends this value that's going to be the product of whatever happens in here. The return is going to come back, and I'm going to have it equal to sum. If I spelled that right, sum, yeah, here we go. Somebody's got to check my syntax as I'm typing. Sum num. And then I can see out, you know, something like the sum of A and B. Well, the sum is and then put sum num. If I sum num. There we go. Sum num. I could have kind of come up with something easier. Or I don't have to take that approach. I'm gonna just cut and paste here. And put the function in here. So instead I go sum, I just change the sum a little bit. So run the function in here. What's it going to print? It's going to return, this function is going to return something. It's going to return an integer. I'm going to print the integer out. And the integer is going to show up on the screen when I run it. If I run this correctly. In fact, let's do this. Alright. So 12, and so I entered in 12, the sum is 4, and the sum is 7. Because I typed in, I changed the numbers around. I got 3 and 4 over here, and I got 1 and 3 over here. So I got 4 and 7. So some people prefer to do things this way and eliminate the number of data members that they have in here. Some people prefer to do them this way, assign it to a value, because then later on the road I have some saved, some num saved. And I can use some num further down the road. So in C++, we take more of this approach to it than we do this approach, but you can do both. Because in C++ we have these things called data members, and then we have member functions. So the data members are going to be all the pieces of data that are stored for the particular object, because we're going to take this and turn it into an object. This is just the basic C syntax. We take it, we put it into an object, we give the object data, and then we give the object some methods or some functions to work with the data. So it can calculate a sum, or it can do some, print something to the screen or something. And we, if we wanted to, we can actually stick this stuff inside of the method. We don't actually have to do it in main. So parts of what we're going to be looking at throughout the course is where should it go in a C++ program. And starting after lunch, I'm going to tell you about everything where everything should go. But as an example, I can see out in here, and this is going to go to my main screen where everything else is. So I'm going to say in the function. And basically have something happen here or something happen here. It's all going to the same console window when I run the program. So in certain instances, we want to have some functionality occur here. We want to have it occur here. One thing to note between the differences of C and C++ as well is all of this stuff is public, because this is a public main program. So main is public in terms of its access method or its access capabilities. In C++, because this is really C that we're looking at right now, in C++ we add 2 more to it. We have private and we have protected that we put on there. Which means here I'm just reading and writing this data and I'm putting it onto the screen. Not very protective. If it's public, I can use it anywhere I want. I can do anything I want with it. If I make it private, then I'm putting access control on the use of the data inside of the object, and I'm protecting it. We build that into the object concept so we can build a hierarchy of objects and not have the foundation fall apart on us. So we can build a structure of classes that are built on top of classes. And we can essentially create a situation in which we have a integrity and solid foundation, and everything works together quite well. Because what will end up happening is if you keep everything public and you just do this all the time, this program can do something different than another program, and it can change the data. We don't have any inheritance. We don't have a hierarchy. We don't have anything going on with C that we do with C++. So, all right, so here we have our data that we added to this, and now let's go back here. So going back to the concept here, this is our blocks. Our blocks are, in this particular case, are showing us our scope, and our functions and our methods will always have blocks to them. So it tells it to begin the section, and that one tells it to end. They always come in sets. Can be nested. You can put one inside of the other one if you want. And here's an example I just showed you live, actually, with the green opening and closing blocks. So all of our functions end up in blocks. Compiling programs, we've kind of seen that already as well. So knowing when to compile often. So compile, run as soon as I make a few changes. Only because if you wait till the very end before you compile, and then you have a problem, it's harder to find it that way. When you do it incrementally, it's easier to find it. So my advice is compile a lot. So to complete the review in terms of the concept of variables, variables hold data. They're actually called fields, data, and variables, depending upon the context that you're talking to them in. In C, we call them variables. In C++, we call them data and fields. So usually called data. And so you have multiple pieces of data. You need to store the data, put them in variables. So we have the declaration, and then we have the thing called the identifier, which is the name. This is just syntax for you. In the data types here, we have the primitive, and then we have the complex data types. So one of the first things that we'll be looking at is the concept of a structure. So let's take a look at a structure. And this is our working program so far. So now we have a function. So I'm going here, this is a function. So I'm going to define a structure. I'm going to put the structure out here, and I'm going to stick it outside of the program because I'm going to use it inside of the program. I'm going to use it like a data type. So this is used a lot in C++, and it's carried over from C. So we defined a struct by calling it struct. So in fact, here's the keyword struct right here. I'm going to call this one person. And then struct is going to have an opening and a closing scope as well. And it's going to have a semicolon at the end of it because we're really defining this thing. What are we defining this thing as? Well, if we talk about the difference between primitive and complex data types hold one or more primitives. So in here I can say integer age, and I can say integer weight, I don't know, character, I don't want to use, well, let's see, string, can't use string, let's see, I don't want to use string yet, integer, birth date, no, I don't know, X, height. Well, I can't spell height, there we go, height. So I got age, weight, and height that's defined in here. So then when I've done this, and this is kind of leading into the concept of C++, what's the difference between that and that? I have to change the name. Person B, person A. It's the same thing. So C++ is written on top of C. C started out with this concept of the structure, which was the first complex data type. Structures don't have inheritance to them. There's no polymorphic behavior. There is abstraction because it's representing all of the data that we're storing for a particular person. Then along came C++. They took the structure and they made it into a class. So now I have this thing called class instead of the keyword structure. So these are definitions, and they have the same, believe it or not, they have the same syntax to them. We have a few more things that we're going to look at in this class that's going to enhance that, give it more functionality. But a structure and a class are the same thing from a basic perspective. Then the class has added features to it. As I mentioned before, we have the ability to make the data, and we also have member functions that we can put inside of the data. Well, we have the same thing with a structure, but nobody does it. So we could put in here integer sum, and now we have a new sum, and let's see, let's just do it here. And we go here, return 1. Let's just return 1 out of there. And then we have this member function that belongs to the structure. Well, we can take the same thing and we can stick it inside of the class as well. Works the same way. But as I was mentioning before, in the class we've added object-oriented features to it. So one of the things that we added was this private and this protected. So we have these keywords here that we put in. Private, protected, so let me just write the whole list here. Public. And you're not going to do them like this. You're going to select one of them. Protected. So you're going to specify access methods for the data. In this particular case, by default, it's going to be private unless we make it public. So if I leave everything out, if I leave this out completely, these guys are all private by default. Because the class and the structure, yeah, they're kind of the same thing in terms of a lot of the syntax, but we have to think about object orientation. We have to think about what we're going to add to this class to make it object oriented. Well, by default, because we're making a class out of it, all this data here is private. So we can make it all public. If we make it public, we get this syntax. Well, now we have sections. We can have a couple of public sections. We have a couple of private. Usually you're going to have one section you're going to call it public. You're going to stick everything in it. You're going to have one you're going to call it private. You're going to stick everything in that. But now these two are kind of equivalent because I changed the default to make this public. So in essence, I can make a person A and a person B and use it the same way. So let's see what happens when we make one. So we'll go down here. Actually, I should probably make sure this compiles just to follow my own advice. Good. All right, so following my own advice. So now I'm going to go down to the bottom here. Actually, I'm going to just comment out this stuff because we don't really need any of this stuff anymore. I'll leave it in here, though, for those people who are copying it. And what I can do is at the lunch break, if you're having problems, you can't type this stuff in, you come up here with a USB disk. In fact, just bring a USB disk with you. And then if you don't have one, and you can copy this off my computer and put it on yours, and you can have a working version of the sample code that we're writing. So we have person A and person B. So what did I do up here? Well, I made, here, we'll keep this actually. We've got 2 pieces of primitive data. Well, we do the same thing when we make a person A and a person B. We use it as a data type. If we want to be consistent, we always capitalize the name of classes. And what we're going to see towards the end of the day is we actually stick this in a separate file as well. We don't stick it inside of the main program. Instead, we can put it into a separate file. Then we can reuse this class in anything that we want to do in the future. So here I can go person A, let's go person A, Barb, and person B, Larry. Let's go Larry. Barry. Let's just go Mark. There we go. So we got 2 names, A and B. And then we can get at these particular data members, and we can set it and get it just the same way as we do regular, but we use this thing called a dot notation. So we go down here and we can say cout. Well, actually, let's set the data first. We can go Barb, because now we access it by the Barb dot, and then we go dot. Well, what do we got? We have all of these things that come up. Well, what do I want to do? I want to go age. Age is going to be equal to 21, and Mark. I'm just going to set the age. Dot age is going to be equal to 35, and let's say we'll set the height. And then we'll just do another one here. Barb height is going to be equal to 10 inches. Mark height. So each one of the marks and each one of the barbs has their own value. Oh, I'll go here 20 feet, 10 feet, 10 feet tall. So really only 5'3", but it's okay. So we use this dot notation. Well, we do the same thing. If you haven't noticed, up here we got a person A and we got a person B. Well, person A is of a type structure and person B is of a type class. I'm using them the same way as if they were the same thing, and they are the same thing. But we have more functionality that we're going to learn and we're going to add to make the class more functional than this. So at a bare minimum, a class is equivalent to a structure. Then we add the class features to it. So this class is going to be talking about how to add the class features to that basic class and how to make that into a real object that's going to do something with it. So if I see it out, I can see out Barb is Barb age. Years old. There we go. So same thing as before with the see in, see out. I can see out, and I can also see in, enter Barb's age, and then go barb.age to see it in, see it out the same way as I would do any individual age or data or some number that we might define. So I'm using them just like any other variable. This is technically, though, anything that is a type of person B is technically an object, however, and this is really a structure. Person A and person B. So let's see, actually, I'm kind of curious if I've introduced any problems. Nope, we seem to be working, which is good. So Barb is 21 years old. How do we know that? Because we set it up here. So let's go back to the complex, and this was describing this differences between primitive and complex. So complex data type is more than one. So both the class and the structure are complex data types in terms of what we got going on. So these are examples of complex. It basically is built from one or more primitive data types. Primitive data types, for those people who have never seen C++ before, you're never going to use short and long. You're going to use a integer. So integers come in a range of values. Data types are defined by the allowable set, or the range of values that you can assign to the type, and the allowable operations that you can do. You can add them, subtract them, divide them. So simplest kinds of data. These are the built-in, commonly referred to as primitive data types, because they're not made of anything else. They're at their primitive raw state. Some people actually call them raw data types as well. I call them primitives. Whole numbers, integers, shorts, and longs, these are the small section. We also have signed and unsigned integers for the below the number line 0 or above 0. Usually I just use int for everything. In embedded systems where memory is a problem, you might only want to use a short, because what if you don't need all the space that's supposed to be allocated for an int? You only use a little bit for the short, so it takes up less space, because the data type is going to determine how much memory is going to be allocated to store that value. For decimal precision, we have floats and doubles. A float is less precise than a double, but takes up less space. So most people will use floats from a... If you've done any embedded systems stuff and you're using data types, you'll go with shorts and floats for the most part, and then unsigned everything, because you don't want to worry about whether it's positive or negative. If you don't know, if it doesn't matter to you, you can get rid of that data too. So you're working with a very small memory footprint at that point. Double is more precise than a float. Either one of them, they both have precisions. Precision is going to be defined by the number of decimal places past the whole number. So we have other ones. We have the character holds a character. Actually, a character can hold a number. It's actually signified by this single quote. The double quotes are for strings. There is no string primitive. There's no primitive string data type in C or C++. It was built into the class string. String is a character array, actually. Boolean holds true or false values. So how to define and declare a variable, we've seen this in a couple of examples, but to complete your review, because what we're doing here is reviewing everything you could have learned in a first C++ course, or C course. We have byte. It's actually byte smaller than a short. I'm going to use something really small. Float, string, and here we have string capitalized, which is kind of interesting. At the break, I'm going to experiment with my string class before I start using it, because I'm wondering why Xcode's got it lowercased. So, which is kind of interesting. I've always used it uppercase with dev. But character, which is going to hold a single character, versus a string, which holds more than one character. So the computer is going to allocate the memory and put a name on it, which is why they call it the identifier for each one of these variables. So how big is it? Well, we can use a function called size of and figure out how big this data is, which is going to tell us how much memory something's going to take up. Why do we need that? Because what if we're going to copy it into something or move it over somewhere else, and we're working with a limited amount of memory? Then we're going to worry about the size of it. Not too many practical applications today, because memory is of abundance. I'm not talking about memory, I'm talking about those 2 gigs of RAM that you have on your system, or 4 gigs of RAM. You know, remember the days when we had 512 or 256? That was a little bit of an issue when you're starting to program, but now we don't really worry about memory. But if you wanted to, you can run this function here. You can go size of and put the thing in there, and it'll tell you how much memory is being used, actually. Why you want that? Because sometimes you're going to cast memory into one memory location into another one or something. So we also have some reserved words in C++, and C, short, auto, break, case. You can't use anything that's used for a built-in command. We also have legal variable names, which is actually kind of interesting because people run into some issues with legal variable names. Can't be a reserved name word. Cannot begin with a number. It has to begin with a character, actually. Can't contain special symbols or spaces. Usually I get my Windows people that will use a space in the name. It's like program files. It's like, I hate it when I see that, because it's like you can't use a space in there when you're programming. Exceptions might be the underscore and the $sign. So here's a legal one. Byte $sign. You can use a $sign. You can start out the value. You're going to use this here if you're going to have 2 words put together. Double. This is not a double. How are you going to double? Sorry. Rum and Coke. You're using a special symbol that's not allowed here. Not legal for two reasons. Yeah, you have spaces in here and you have reserved words in here. Those are the two reasons. You're going to notice that I'm going to use this probably exclusively when I have two words I want to put together. I usually capitalize the first, they call it camel casing. So I'm going to put in here integer, lowercase to begin out with, and then height. So the first character of the second word is capitalized and there's no space in between. I always started out with lowercase. And I always name the data with lowercase. So you can do this in your classes as well, actually. In fact, some languages, well, Objective-C kind of promotes it more so than C++, but we'll encourage you for a data member to use lowercase to start it out with. It has to start out with a character, but it should be lowercase. The class name, uppercase. So when you look at something, you know if it's a class or if it's a variable, object or variable, given its case sensitivity. So, or given its case, I should say. Literal values, they're constants. So like pi, 3.14, you know, you never going to change. So character literals, string literals, hello world can be defined. In terms of initializing variables, I showed you before we use the assignment expression, which is the equal sign. And it copies the information from the right to the left. So integer age is equal to 15. Character letter grade is equal to B, so on and so forth. Why does the size matter? Because we have casting, type casting. So we can take each data type that takes up a different amount of computer memory and create the variables, and then sometimes we want to change one into the other. Well, we have a problem because we can't put a large data type into a small data typed variable. So if we have a short s that is equal to 5, and then we have a long L which is going to be equal to s, that's going to work. But if we go here, we got a short, we got a long, we could put a short into a long space. We can't take a long and put it into a short space because we're going to truncate some of the memory, which means we're going to lose some of the precision that we're going to have, or we're going to reduce the amount of memory we're actually using, and so we're going to have to take something out. Something's going to be lost in the translation. In C, they call this typecasting. When you typecast, when you change an integer into a float. I don't like typecasting. I would rather do something in the nature of, let's see, upcasting or object casting, which is safe, versus typecasting, which is not safe. And I'll explain that when we look at objects in the is-a relationship. But if I were to say like floats, my floats, it's going to be equal to, well, let's say integer. But no, it's going to be float. We're going to cast a float to age. What I just did is I took, this is an example of typecasting. I took a float and I put I changed, this is the cast here. I changed age, which was an integer, and I put it into a float. Well, depends on whether it's going to fit. I can also do something that's unsafe, actually, and do like a, a long, and basically my point I'm making here is that although you can cast and you're not going to get, this will actually work. I could actually come up with a situation in which I'm going to take something really big, a long, and put it into a short, and then it's not going to give me a compiler. It's going to work just fine, but when I run the program, I'm going to have problems. So long story short, the rule of thumb is if you're going to use it as an integer, define it as an integer and only use it as an integer. Don't cast it to anything else. Don't do this. That's bad. However, there are some cases in which people have to add things together, subtract things, do some manipulation, and you get what's called a type mismatch error, which because you're trying to add a float and a double together, which you can't do. They have to have two like kinds in order to add them together. And if that is the particular case, then you'll end up having to cast eventually at one point. Just make sure the cast is safe before you do it. So, operators, addition, subtraction, division, all of the simple things you get in basic math work the same as most of the algebraic operators are the same. Typecasting, this is what I just showed you a few minutes ago with the float and the integer age. I did a integer to a float, which is probably a safer operation. So this occurs when you want to put something larger into a something smaller, or vice versa. You can possibly lose precision. Conditionals and Boolean expressions. So what we've actually looked at, and believe it or not, this is pretty much all the syntax you get. There's not very much outside of just declaring variables or declaring complex data types. We have another one here I didn't go over, and I can show this one to you real quick here. It's called the union that's supported. So we use the word union in here. Union. And the union, person C. Get rid of this instance variables. I didn't want to do that. Let's just do it here. There we go. Oops, this is B. There we go.
Now and again one class B.
Excuse me?
Now and again one class B.
Oh, what did it do? I don't know what it did. There we go. It auto-corrected it and did something funny with it. Well, that's the other thing I don't like as well. So sometimes you might notice, and I'll show you over here with main, this opening bracket can go here, or the opening bracket could go on a new line. Dev will put it on a new line. Xcode puts it on the same line, because Objective-C puts it on the same line. I put it on a new line. So it doesn't really matter how you do it. Also, in terms of documentation, usually I get a couple of students who ask me on the first couple of days of class, how do you want it documented? This is what I mean by documentation, internal documentation. There are some instructors that actually have this whole header thing you put on the top, you know, like my name, my age, how long I've been in school, what languages I know, all the biographical stuff about you. Put your name on it, and if you're going to put your name on it, go up here and say, by Barbara Hecker, you know, or something. Just because when I download it from the EMS, I might put it might be like 5 different ones. I might be comparing it, or I might be looking at something. I'm not going to know whose it is once I download it. So put your name on it, that's all I ask for. You don't actually have to do this either. You don't have to comment in the code either, which is really bad practice actually to not do. So you can practice, I'm not going to worry about your syntax in here. You can practice anything you want. Let's just call this weight actually. Weight, there you go. So union and weight. So a union and a structure are pretty much the same thing. They're both complex data types. We don't have a union in a class though. Union is only a form. It's a special type of structure that takes up less memory because only one piece of data at a time can be stored for it. So in here I can say integer age A, and then I can say double age B, float age C, or I can say, actually here we go, ounces, this is weight, ounces, pounds, kilos, I don't know. I have 3 different measurements, and there are one's in an integer, one's in a float, one's in a double. So I can create a weight out here. I can say, use it just like before. And so I can go weight, my weight, and then I can go my weight. If I put a dot in here, I'm going to say, well, what do I want? Kilos? Do I want, don't I want here ounces? Ounces? But if I do that, and then underneath it, if I go here, that's an integer, so I can say equals 1, and then go my weight dot kilos is equal to 12 or something. This one is going to replace this one. So only one of them at a time can be assigned. So it removes, so this creates a section of memory that allocates a space for an integer to hold the age, actually 3 integers to hold the age, the weight, and the height. This one allocates only 1 space. And it's going to hold either integer, or double, or a float. So it's going to be as big as the largest one that's in here. And it's going to store either an integer, a double, or a float, but not all 3. So union is a lightweight structure that only holds 1 value at a time. So that's the differences essentially between the union and the structure as we look at it. But, But outside of that concept for basic C, now you have what's called flow control. Flow control is how is the program going to exit? Excuse me, how is it? Well, that's how it's going to exit, but how's it going to flow? So that's where we get the if, the then, the else's, the cases, the switches, and all the different ways of manipulating the flow. So at this point, hopefully you've gotten the idea maybe from looking at some of the way the examples are working. We're starting at the top of main and we're going to the bottom of main and we're going sequentially line by line. That is C. That's characteristic of C. In C++, we don't do that. Instead, we make a bunch of classes. We make instances of the classes, and then we let the classes interact with each other. And the classes run each other's methods and send data back and forth between the classes. We still have the sequential processing going on, which is interesting, because it's all controlled by a main. And main is considered the driver program. So we take main, and we put in there all the objects that we're going to create, and we let the objects float around and do everything they're going to do. And we somehow end up with a working program at the end that always runs differently depending upon what the user is going to do. Well, we can also control the flow this way, where we can put up a menu. We can do all sorts of things where we have a start and we have some sort of end to it. And this is just showing you a typical flow chart of the concept where did a break, did something happen? Are you lying? Did you pass the class? Did you do this? Did you want to do that? So decisions to be made. So you have the concept of the Boolean that comes in with this. The Boolean is a true or a false. So we usually check to see if a condition is true or if a condition is false. And then we proceed or we don't proceed. So everything reduces down, when they call this evaluation expressions, it always reduces down to a Boolean in the language. So the Boolean is something that resolves to either 1 or 0, true or false. So you can get Booleans in several different ways, simple or complex. And the Booleans are going to be used later on to make decisions to change the program behavior. So then we have our relational operators that we use with this. Greater than, less than, equals. So which is interesting because new people have to get familiar with the equals versus the assignment. Because most people would, make the mistake of going, well, does x equal y? And then you put an equal, well, x now equals y. Because C++ and C allows you to do an assignment in an expression for an evaluation. So you can make x equal y and it's going to come out true. Because if they're both integers or something, they're both same data type and the operation actually works, the assignment expression is going to return true. And then the thing's going to work. And you're going to go, why this is not working? Because, well, you have a logical problem where you should have used a double equals for comparison instead. I'll show you some examples in a few minutes, but that's a common pitfall some people run into. You can string them together. You can use the not equals to as an example. Here's some literal expressions where we have 5 larger than 3, here, let me go back out here. So let's get rid of this here. I'm going to take this out. Clean this up a little bit. Take my union. I don't want my union in here either. Hopefully I haven't messed up anything else. Comment out this. Well, actually, let's just do it at the top here. So I can say if something, and then here's the syntax. Oh, this works the same way with everything in the do, the while, everything. We have an opening and we have a closing. And this is what I call the expression in here. So if 1 is larger than 2, which is not really the case. 1 isn't larger than 2. Then we're going to do something. And then this is where we have those opening and closing brackets again. So then if you put the opening and closing brackets down here, you can easily see, and then people do this. And they go, end of if. So this is the end of the if. Because you can put nested ifs inside of the ifs, inside of the ifs, inside of the ifs. So example here, let's make this so it's true. Well, actually, let's not make it so it's true. We just go in here, see out. Never happening. Never happens. It's never going to happen. But we can put in an else. So let's say, well, then we put the keyword else in here. And then again, we have opening and closing brackets. And we're going to put here see out. Always happens in this particular case. because 1 is not larger than 2. Or I could nest inside of it and then go like this as an example and do the double negative. If not, well, it is not. If it's false, then it's true. Then this one's going to happen. And this one will happen. That never happens will happen because I switched the logic around. And notice I put in 2. I have now nested in here. Well, I can do this as well. I can use and 1 is larger than 4, which it's not. Or, so I can nest them together and inside of them put them this way. But what you really want to do is think about this logic here and go, if true, actually you can put the keyword true in here as well. True and true. Then that's going to evaluate to something. If true and true, then it's true. If true or true, one of them's true, but the other one's true. So this one here will always evaluate to this one will always happen. One of them's going to be true or false, so it's going to be always true. So this one will happen in that particular case. So the problem now that most people run into is like, how do you get the logic correct? I happen to find the if and the else kind of the more complex way of doing it. We have this thing called a switch with case that works with a different pattern to it. And I'm looking at the time. I'm going to save that for after lunch actually. But what we're looking at in terms of the expressions is something that's inside of opening and closing brackets that's going to evaluate either true or false in our particular case. So 5 is going to be larger than 3. That's true. 6 not equal to 6. False. 6 is equal to 6. 4 is smaller than or equal to 2. And you can mix them together. C, character C, not equal to character B. It doesn't have to be numbers. It can be characters or strings. But you can't do a string comparison. You can't say, is this string equal to another string? Strings are holding memory addresses. It's never going to come back correct. So there are a couple of exceptions. You can't do this with strings. Variable examples here, you can go number 5 is equal to number 1 is equal to 5. Short number 2 is equal to 7. Boolean result is equals number 2 larger than number 1. It's going to assign the Boolean true or false. And we have Boolean in C as a data type. So it's going to hold a true or false for us. It also can be used with 1 and 0 as well. Because we can do this. If integer I, oops, I'm going to caps here, integer I equals 1. That'll come out true. So C++ and C allows us to do assignments, evaluations, booleans, direct booleans, true, false. So we can put it here, which is what we're really looking for in this particular case, if true. That's legal as well. So lots of flexibility in C or C++. Other languages don't allow you to do don't allow you to do assignments like that or to do expressions like that. So there's a lot of flexibility in the C language. Here's our ands and our ors. Well, we just stick 2 together for the comparison. So the operators check the multiple conditions. Here's the and. Needs both the left and the right to be true, or the or. So, yeah, here's some examples. 6 is larger than 5, and C is equal to B. Well, it doesn't. So they both have to be true. So those evaluate to true. This one evaluates to false. So here's the textbook example of it. I just showed you the source code a few minutes ago. So if we do something, we use the if statement. And we can decide whether or not to execute some code. So here we have if, and then this is going to come out to true or false. And so here's another full example. And these examples you can cut and paste them and stick them in to your compiler and run them, and they should work just fine. Start's 5 and ends 19. If start is larger than end, see out A, else see out B. Well, actually, there's no else in here. This is a mistake. So this is going to get, if start is larger than end, it's going to see out A. Otherwise, and always, will see out B every time you run it, actually. And here's what I said before. People like to put in comments, end the if, end of main. So you know, further down the road, you know what the closing bracket was. So in this particular case, we have A and B being printed out because we didn't put an else in here. So what happens inside of the opening and the closing bracket is just within inside of that scope. So underneath that, it's going to start. Yeah, B will always print out in this particular case because it's outside of the condition. It's outside of the expression. So we can fix it here by, what I got here, part 2. Where we've got the, no else in here, but we have the, well, it's just repeating it over again. So it's printing it out. So now we have B. Oh, we're changing the direction here. Changing the direction so A doesn't get printed out and just B gets printed out because we changed the direction on this. So we only get one instead of the other, instead of both. And here's the else that I was expecting to be in that example, but it wasn't. So the else expression here, I simply include the word else. In fact, a lot of people like to do this with it, which makes sense as well. I put that comment there so I couldn't do it, but you can put it on the same line. Because you can actually write the entire program on the same line. So a lot of people will do this actually. So it's clear to know where the else is. So it doesn't really matter what kind of spacing you use. The whole program could be on the same one line of code. So notice only once those statements get executed no matter what, in this particular case because of the else. You can put multiple else's in there as well, and you can use an else if in there. So here's the rewritten code with the else. So it should print out B instead of both of them. Or one or the other, but not both. So here's the else if, which is going to do yet another comparison. So if you're going to have multiple, you can have one else at the end, which is going to be the catch-all for the entire construct. Or you could start out with an if, and then go an else if, else if, else if, else if. Okay, else, which is sort of like default, if you think about it. Because if everything else doesn't exit out, then the last else will stop the program. My ear is bugging me. Ever get like a ringing in your ear? This is a good time to stop because my ear is bugging me right now. And I noticed it's almost noon and we have barbecue. So let me stop this video. So what we've covered is basic syntax. After lunch, when we come back in, I'm going to hit with the class concept and finish off this little lecture, which we're about more than halfway through already. Although it says 165 slides, it's not going to go that far. Finish through, and then we'll start making classes. So I'm going to show you basic syntax for C++. We've covered mostly C at this point, not too much C++. So I'm going to start covering a little bit more of the C++. This might be a review for a lot of people, and it might be brand new. If it's brand new for a lot of people, just be patient and take it step by step. It's very similar to Java, but a little bit different syntax. And don't panic at this point. If this is not brand new and old stuff and it's too slow for you, don't worry. After lunch, we pick up the speed a little bit faster. So I'm purposely trying to start out slow with the syntax and ease everybody into it, especially if you haven't been programming in a while. The pace will definitely get faster after lunch. Only problem is it's going to be a double problem for those people that are just learning this for the first time. So I'm not going to be able to satisfy everybody, so I'm going to try and hit the happy medium in between. But during the lunch break, feel free to also come up with any questions you might have that I skipped over something extremely fast. Because what I can do is take a list of topic suggestions that were, I want to know more about structures. I don't know how to make a structure and assign it at the same time or something. Or I want to know more about data. Can you explain data types to me again or something? And then I can add that, because if you have the question, most likely somebody else in the class might have the same question. So we'll do a little bit of review as well with some special topics that people might have. We're going to get through today. We're going to get through the boot camp lecture, this one here. We're also going to get through creating simple classes. Tomorrow is when we really start the C++ code. So if you're looking and trying to think ahead, oh my god, the entire weekend's going to be like this. No, we do pick it up. We hit object orientation and C++ tomorrow. And unfortunately, I have to get everybody on the same page before I can do that, because otherwise it's too complicated for some. So, questions, comments, concerns at this point? No? I see a lot of interesting faces. We do take attendance after lunch, so when you come back, you'll make sure to sign the attendance. So it's now 11:57. Here, let me stop this video. Unless my clock is wrong.